Hey guys, this is going to be our lesson video for 6-7, dealing with similarity transformations. Just wanted to show this really quick before I slide it up to the other screen. Alright guys, so before we start this lesson that we're going to run through really quick, by the way, sorry that I'm not in class today. I'm at home for a funeral, so please let me know if you have any questions. You can either comment on Schoology or I'll be back tomorrow, so no worries, we will take questions before we go any further. And this is actually the end of our chapter, so we're going to wrap up this chapter, and actually I think this is the end of our chapter, but we'll talk on Wednesday about all of that. Before we dive in, huge, the start slide right there is giantly important that this, please write this on your notes. This is your composition symbol. You're composing isometries or composing transformations. What you do first is the closest thing to the name of the shape. Because if I was writing a composition, like let's say I'm going to reflect, then translate to a triangle, I do my translation first, then I do my reflection. So you don't read this as a reflection, then a translation. This is translate, then reflect. It works from the closest thing to the shape away from it. So please pay attention to that before we dive in. So when we look at problem 1 here, dealing with our similar figures, we see that this is actually going to happen first, and this is actually going to happen second. So go ahead and try that for just a moment. I'm going to pause the video to be able to draw some things on here and not waste time in the film. So try this on your own. What you want to think about first is where will D, E, and F be after the reflection, and then what will the points be after the dilation? So we would actually be able to walk through this process completely mathematically without the image here, but I'm going to go ahead and show it to you both ways because in one of our future problems down here it says to draw the image, but as I know most of you probably won't want to do that. We don't have to actually have the graph or the image drawn to make this happen. So the first thing we want to do is what I have underlined in red here. We're going to reflect the y-axis. And when I reflect the y-axis, I know that my y values actually don't change at all, only my x values do. So what I've done here is take each x value and make it the opposite of what it was, because when I reflect the y-axis, all my x values just become the opposite. So I see my d prime, e prime, f prime would be there in the red. Then I have to dilate by a scale factor of 1.5. So I'm going to dilate by 1.5. And I do it from the origin. Most of our dilations are going to happen from the origin. I'm just going to multiply each of my values by 1.5. So I've gone through and I've multiplied each of the x and the y values by 1.5, and that new shape ended up at negative 3, 0, right here, negative 3.5, 6. So, negative 1.5, sorry, not 3.5, 3 halves, 6. Would be where E was, and then negative 6, 3. So our new reflected and dilated shape would be my green triangle right there, and this would actually be D double prime, E double prime, and F double prime, since we have changed it twice. Here in the red, we would have had our single prime, and in the green is the double prime. So go ahead and try the got it. You do not actually have to sketch it. Now, if you would like to, grab some graph paper over on top of the bins and go ahead and sketch it, but you do not actually have to. So if you want to try it mathematically, go ahead and do that. If you want to sketch it, go ahead and do that. Pause the video, come back when you have this finished. So I'm going to go ahead and capture this so I have it up on the TV. The big thing that we see here is our translation 4 units right and 2 units up, then dilated. So we know the translation has to happen first, then the dilation happens. So if we wanted the translation, this is just a change on the x and change on the y. Then my dilation scale factor is going to shrink my object. So again, I'm just capturing that to get it up on the top screen so I have a little bit of space to work around. Again, if you have not finished solving this, finish it before you move on. All right, so again, I start in my blue, then I transition to my green, then I transition to my red. So the first thing we do is shift 4 units right and 2 units up, which when I think about shifting to the right and shifting up, that's going to take my x values and add 4, and take my y values and add 2 to them. So I wrote up my original points, then to every x I add 4, and every y I add 2, making sure that work is correct there. And then our dilation factor of 0.5 tells me that all of my values are going to be half the distance away from the origin that they currently are. So I half each of my x and my y values to find my final points. So this would be L double prime, this would be M double prime, and this would be N double prime. So if you wanted to put those on a graph, that would be your final location for LMN, now translated to the double prime. So if we want to describe a translation or a composition of translations, we have a lot of different options. So here I see RST translated to PYZ. I want you to pause the video and think up two different routes that we could take to get RST to PYZ. So pause the video. Oh, well, I'm recording, but just knocked out my screen. There we go. So the two different routes that I'm hoping you would have thought of is that I can go left then down or down then left. So the route that I've taken here, I reflect the y-axis, then I dilate, and then I reflect the x-axis. The other route that I could take was reflect the x-axis, dilate, then reflect the y-axis. And there's always more routes than that. I mean, we could go to California before we go to Florida. So we know there's really infinitely many routes if we want to get technical. But this is one way that we can do this. And the reason that I have your points notated here, that I continue to say RST, RST, and of course these would be prime, but you want to check that your points line up how they should, especially in a triangle. T over here, we're told, has to correspond to Z. So make sure that when you end, T would actually turn into Z. S has to correspond with Y, so make sure that S actually corresponds to Y. And what we have done here, the setup does work, so this is an accurate way to translate from RST to PYZ. So in problem 2 here, they got it. Same basic thing. So I want you to write out the entire composition that takes us from ABCD to MNHP. Pause the video, try this on your own. So I want to kind of reason through this with you guys because there's a few different options that we can take here. So one thing that we noticed just to begin with is that I have AB has a length of 4 and NM has a length of 2. Sorry, I lost my thought in my head. So the other thing we want to identify is AB goes to MN, and that has to be in that order. So A goes to M and B goes to N. So if we really codify this, let's highlight A as yellow. And then if we highlight, let's say, D in green, that would have to go to P. So we see there has to be some kind of reflection that happens here because my shape has to flip itself over. So the common mistake here would be that people would just kind of try to glide it over and then shrink it down. But if all I do is translate it and then dilate it, my points will not be at the right location. So a reflection has to happen here. So that's the first thing that we should identify is we have to do a reflection. So now that you've seen that, keep working to try to get every single step of these rigid motions and your dilation. Okay, so we've identified that we need to reflect, and we know that we're going to reflect the y-axis to make that happen. The other thing that you could have also seen is the comparison in the slopes of the slope of NH and BC compared to like the slope of AD. These are different slopes. So hopefully that would have jumped out at you at some point. So if I reflect the y-axis, I start at a point A of -6,2. So my A prime would now be out here at +6, +2. And why I'm pointing out where your A prime is we already know that the scale factor is 1/2. So when we dilate, excuse me, every point, every x value and every y value is going to be halved. So if I think about halving my x and my y values, will that land me at my final point M? It does, in fact, get me to my point M of 3, 1. So all I would need to do is reflect the y-axis and then dilate by a scale of 1/2. And we would actually be completely done with this. All we have to do is one reflection, one dilation, and it will get exactly where we need it to be. So in problem 3, it's asking us that if there's a similarity statement, we need to write it. So we see that we have two triangles, so I went ahead and wrote that if there's a similarity statement, we're going to have a triangle similar to another triangle. Now what I see immediately is I have angles that are congruent sizes. So angle P is congruent to angle T, so those would have to correspond with each other. So P would be first, T would be first, or whatever order they come in, they have to correspond with each other. Angle A is the same size as angle N, so that then would make A and N be second. And then this third angle has to be the same too, because if two angles are congruent, then the third remaining angle also has to be congruent. So then Q would be congruent to O. So whatever order you have your points in, there is a similarity statement as long as P maps to T, A maps to N, and Q maps to O. So go ahead and try number 3 on your own using side lengths instead of using angles. All right, so when we look at these side lengths, we know that the longest side would have to correspond with the longest side, shortest side with the shortest side, etc. So I went ahead and set up, if these are similar, these ratios would all have to be equal. So I have my larger shape on top, so I take the longest side compared to the longest side, then middle side compared to the middle side, and shortest side compared to the shortest side, making sure that I have my bigger values on top. So now let's think about what would these ratios be if I simplified them down. Well, 20 and 16 can both divide by 4 and become 5/4. So that would have to hold true for each of these. Well, to go from 4 to 12, that would multiply by 3, and this does not hold true. So we see right there our similarity falls apart. And we could also compare from 5/4 to 12/10. This would actually be 6/5 as opposed to 5/4. So we see that we have all these different ratios here. So what that really tells me, sorry that's moving, is these are not similar shapes. So when we look at problem 4 here, if we are designing a logo and trying to change our lightning bolt, so what do you think? So a new company is using a computer program to design its logo. Are the two figures used similar? So if it used a computer program and stretched it, are these two images similar? Yes. How did they get there? Well, we know that one's larger, so there has to be a dilation. And since the one is not on top of the other one, we know that there's also a translation. In problem 4, just to wrap up our lesson here, are these figures similar? Well, we have the one smiley face is upright and larger, the other one is rotated and smaller, so we see that yes, these would be similar. There's a dilation that happened, and there's a rotation that happened. So our two there would be dilation and rotation. Hopefully this all made sense to you guys. Hopefully you also have your practice as well. So let me know if you have any questions, but tomorrow we'll wrap up the chapter. Please work on your practice with the rest of the class time that you have, and please be nice for the substitute. I know you're probably going to get done with your work, at least some of you, before class time runs out. Keep it quiet. 7th grade has AO, so please behave yourselves, get your work done. I'll see you tomorrow. Keep working hard. Thank you very much. I appreciate your time.